Okay, so defining coordinates using functional notation. So what is a functional notation? For example, you might have seen we write y is equal to x plus 1, linear equation. You might have seen y is equal to x squared plus x plus 1, quadratic equation. So you can go on like that, x to the power 3 plus whatever, x to the power 4, whatever, right? So the same thing, you can write y is equal to p plus 1. Same thing you can write y is equal to p squared plus p plus 1. So now you will understand x is a variable, p is another variable, right? So you are just giving a name to a variable, right? So name really does not matter. We have to understand it's a variable. Yeah. So in functional notations, we write this one as f of x is equal to x plus 1. Okay, this is a name as well, right? So you can see x is the independent variable here, y is the dependent variable. Why? The reason is when you put 1 here, y is going to be 2. When you put 3 here, y is going to be 4. So that's why this is called independent variable and this is called dependent variable. It depends on x, right? So this functional notation means another way of writing the dependent variable. Y is written as f of x. F of x is nothing but y. Now, if one write g of x, still the same, because this f, g, whatever is a name. If someone write h of x, it's the same, right? So it's a function. This is a function which is y. Y is nothing but this, right? Why this functional notation is important? If you just look at this one, you understand this is a dependent variable, right? Explicitly, this inside will tell you it depends on what? It depends on x. Depends on x. So that means inside will show you the corresponding independent variable. Yeah? Okay. So similarly, if you want, you can write this one as g of x squared plus x plus 1. This one you can write if you want h of x to the power 3, whatever. Now, in this situation, now the independent variable is p. So what you have to write, f of p now. F of p is equal to p plus 1. Because there you have to indicate the independent variable. This one can be any simple q. P is p squared and whatever. So this is the functional notation, right? Now, I'll get a small example here. Suppose it is given to you that y is equal to fx is equal to x squared plus 5x plus 6. Now this is true, right? Because y is nothing but f of x is another way of writing it. This has advantage. Why? It will show you the corresponding independent variable inside. Now if you plot this one, this value should be minus 3 and this should be minus 2. You can factorize it and look at it, right? And this is 0. Suppose this is 1 here. Yeah. Now, there is a way of defining a coordinate. Suppose I need to find the coordinate at this point. So x value is 1. What is the y value? So what you can do, this one, you can put this into here and here. You can find the value. That's no problem. So if you do that, you get, I think 12, right? So this value should be 12, right? However, using the functional notation, you can write this one as 1 comma you are substituting this one in here or here means you are substituting that value over here as well, right? So what I'm saying is f of 1 is nothing but 1 squared plus 5 times 1 plus 6, which is going to be 12. So either you can use this value here or you can use this value, this notation here, right? So I will do both 112 or one can write 1 comma f of 1 like this. So that's the benefit of having that. Okay, now for example, take this point over here. Suppose that point is A. You need to find the coordinate at this point. So we understand the x value is A. Now instead of you substituting that into the equation and then get the answer, what we do is the function is defined as f of x. We write f of A. Right? F of A. Now this is it. This is how you work with that. Now importantly, we'll try to understand the difference between fx and the difference between fx and fa. Difference between fx and fa. This is a function. Right? Function means it's a curve. It's a plot. A lot of values because x is changing. What about this? F of A is a value. Example. Suppose this is your f of x. F of x is this whole curve. F of x is this whole curve. Now A means this point. A is this point. So f of A is going to be the y coordinate at this point, which is this. That is f of A. Right? So now from here you will understand f of A is a point, this point, y value. So f of A is a value. F of x is a function. See? Yeah, so that's the difference. Okay, so we'll discuss another question. Now let me create a question. Consider fx is equal to x minus 2 squared plus 3. Right? Now, A, which is capital A point, is A comma f of A, is a point on fx. Right? Find the distance. Find the distance from origin to a point. Suppose you have this question. Now, firstly we'll try to visualize this. It would be something like this, where this point is 2 and 3, right? Because you can find the turning point from this, right? And that. So it's going to be 2 comma 3. So this point is 2. This point is 3. Now this is f of x curve. Now a point can be here. This is a point. The x value of that is a here. So y value of that would be f of a. This is the picture. Origin is here. So what you need to do is you need to find the distance. You need to find this distance. This distance d you have to find. Right? Now listen to me carefully. I'm I'm going to get a point here on the curve, which I'm going to say x comma f of x. Right? Why I'm saying that? If I choose a point here, which is x, right? This x point is on the curve. That means this point will satisfy the equation. This x, you are going to substitute into the function which is x again. You are overriding x. So if you put x over here, so that means you are putting that x over here. So that means the y coordinate would be f of x, right? So you choose a point, you choose a variable to define this point, x coordinate, which is x. This x, we assume that this x coordinate is going to satisfy the equation or the line. Satisfy means on the line. If that happens, the y coordinate is automatically f of x. Again, if you choose this point to be a, not a, because we have used a, suppose p, then this coordinate is going to be p, x coordinate is going to be p. Then the y coordinate is going to be f of p. It's easy, right? Now, since x is defined, right, we typically consider the point to be x. So I'm going to get this coordinate to be x. So the y coordinate would be f of x. When the x coordinate is x, the y coordinate is f of x. So if you put this one into the function, the y coordinate is f of x. Yes, indeed, that's what you have seen here, right? Now, before we do this question, we'll try to find out the distance from O to this point, right? So let's do that first. So I'm going to firstly find this distance, which I would say capital D, right? Capital D. Now you can see capital D is equal to, I'm going to use the distance formula. Distance formula is y difference, which is fx minus 0. The reason is this is 0, 0, origin is 0, 0, squared plus x minus 0 squared square root. Right? So now, if you simplify this a little bit, you will get fx squared plus x squared square root, and that is d. Now, if you carefully look into this one, you will see x is a variable. If x is a variable, d should vary with x, right? So d is a function of x then. How do we know that? X is here. If x is this point, you get d, this distance. If x is defined at this point, then you can see d is changing, right? See? That means the original length I showed you is short now. So that will tell you that x is changing point to point. Accordingly, d is changing. Okay? So we say d is a function of x. D is a function of x. The meaning is when x is changing, d changes. Right? So d is changed. So we mathematically write that as d is a function of x. Right? Now, in this question, you have to calculate simple d. So simple d you can easily calculate. Simple d you can easily calculate. The reason is simple d you can easily calculate. Why? Because it's a precise point, right? So that would be fa minus 0 squared plus a minus 0 squared square root, so that d is equal to fa squared plus a squared square root, right? So now this a is a specific point, specific x coordinate. A is a specific x coordinate, it's not a variable, it is a fixed point, right? Hence, this d is a fixed value. So we have to clearly understand the difference between this fixed length d and this distance capital D. This distance is changing. Why? Because x is changing, because we put a variable here. The coordinate here is a. A is not a variable, a is a value, right? Like 5, right? So d is a fixed value, capital D is a changing value, the way we have defined it.